Hello, everyone. Thanks for joining us. Welcome to Disaster Planning and Recovery for Stability Programs, a Stability Hub webinar. We would ask that you turn your camera on if possible, but stay muted unless you're asked to comment further on a question. Please use the Zoom chat feature to submit your questions or comments. If desired, address your questions to a specific panel member. In the absence of your questions, we've assembled an interesting array of frequently asked questions. This session is being recorded and will be available in the articles and webinars section of stabilityhub.com. Our program today is based on the Stability Hub July newsletter article by the same name. I'm John O'Neill, facilitator of the Pharmaceutical Stability Discussion Group and editor at Stability Hub. I'll take us through the main points of our topic. All are welcome to comment or ask questions throughout today's presentation using the Zoom chat feature. Joining us today as our panel of subject matter experts are Jeff Carr, industry consultant and contributor to Stability Hub, Jeff Cook, Chief Operations Officer at Parameter Generation and Control, Aideen Glynn, Quality Manager at Q1 Scientific, which is in Ireland, Chris Latos, Manager for Stability Services at Hollister Incorporated, and Walter Ralph, Stability Hub co-editor and founder at Sagana Consulting. In addition, we'd like to think of all of you as an extended panel, contributing your knowledge and experience to the discussion. So with that, we'll get started. I have a quote from a famous stabilitarian: "If you fail to plan, you are planning to fail." You might recognize the signature of Benjamin Franklin, one of our country's founders. And you might ask, why do we think of him as a stabilitarian? Well, he was a wise man with lots of inventions and great in science, but he actually once showed up to a pharmaceutical stability discussion group meeting in Philadelphia and chatted with us. We have pictures to prove it, or at least that the actor that played him was there. But since you're part of this webinar, we know that you're not failing to plan and you're not planning to fail. So we thank you that you're part of the process of making sure that never happens. Disasters do happen, but they're low on the priority list. Disasters occur whether we plan for them or not, but planning ahead can mitigate their impact, and recover from their damage can make a big difference in corporate success. While we can't control the nature or the timing of such events, we usually have ample opportunity for risk assessment and developing potential courses of action. The real tragedy is that we often delay or deprioritize taking the necessary measures. There's always something going on that keeps us from getting around to doing this. What about regulatory input? Are we required to do disaster planning? While not having specific regulations requiring those plans, the FDA strongly encourages all medical product stakeholders to develop and maintain such plans for emergencies, aiming to minimize disruptions to patient care and ensure continued availability of essential medical products. Disaster plans should be adaptable to various situations and allow for quick adjustments based on evolving circumstances. We only need to look back to the pandemic to see what came on us very quickly, and we needed to vary our plans because it interrupted our supply chain in a very drastic and sudden way. Some key elements of an effective plan: supply chain resilience, identifying multiple sources for supplies and materials, alternate delivery routes and backup distributors, having contingency communication, establishing a clear communication plan for stakeholders, including the healthcare providers, patients, and regulators, having a site vulnerability assessment, identifying the manufacturing sites or distribution centers that are particularly vulnerable to specific things such as flooding, earthquakes, those sorts of disasters. Ensuring the safety of medications during and after a disaster, including protecting them from temperature extremes and water damage. Once our systems go down, we don't have a lot of control over those extremes. And so we want to think about that. Having a business continuity plan to ensure that operations can resume as quickly as possible after an event. And then regularly testing and updating our disaster plan. So those are the kind of areas we want to be thinking about as we go about our planning process. Who should be on our radar, or what should be on our radar? Things like wind generated by tornadoes and hurricanes, water that comes from hurricanes or large storms, failures of dams, barriers, or internal equipment systems, Even a leak in-house that starts on one floor and drips down onto your equipment on the other constitutes something we need to be thinking about. Things like earthquakes, fires, both internal and external, as we've seen recently in Los Angeles, a lot of companies impacted by that. Equipment failure, loss of power or water or functionality of equipment, loss of the computing ability of our company, system failure or hacking. If you think back several years, Merck in the US was a big example of being a hacking victim. Political upheaval, such as wars, terrorism, or even new regulations that come along, the pandemic, and any environmental impact that we might have to deal with. Human error, misunderstandings, or failure to follow procedures can generate a major disaster for a company. And business failure. The company suddenly closes up overnight. We've had a couple of meetings where we were at a host company in the pharmaceutical industry, and people came in during our meeting and pulled out everybody from our host company to inform them that they were now unemployed and that they might even be closing down the site that we were at. So it happens more often than you would think that these kind of things can occur. And you might be able to think of other things as well. Who should be in the room? As in any planning endeavor, getting the right people into the room and conducting a thorough risk assessment as an exercise is a natural beginning. It's a great advantage to mine the experience of as many stakeholders as possible. And we've identified more than 30 stability stakeholders and functions that often work with the stability function. And we want to consult those folks regarding disaster planning, not leave them out. The war stories of industry colleagues beyond our walls are equally valuable. And I think it's a great time to reflect on some of those stories and hear from some of the people that are involved with planning as our partners. So Jeff Cook, if I can go to you first, you operate out of Black Mountain, North Carolina, and last year you were struck by Hurricane Helene, I believe it was, and that impacted a huge amount of folks in the industry. I was wondering if you had about three main takeaways from your experience for disaster planning and what you would do in the future.
Certainly, John. Yep. Black Mountain, Swannanoa, North Carolina was ground zero for all the flooding during Helene. So, you know, the quote from Benjamin Franklin is exactly right. And, in an emergency, we all fall back.
Oh, we just lost you to freezing. You still with us?
Maybe I'll try to log back out and back in.
Actually, we just got you back.
Okay, can you hear me?
We can.
Yep.
Okay, yes. So Helene definitely knocked us out of business for weeks. Beyond the initial disaster, it's the recovery, we're still in certain ways reeling from it. So I feel like one of the biggest takeaways is having a good network of not only within your company, but other like-minded companies that you can use as resources when you need to. Um, Writing disaster planning into your SOPs may help get some buy-in from levels of management that might not be as concerned as you are or realize the level at which the risk is. So I'd say buy-in from management is absolutely key. Preparation and even using your imagination for the worst. I never thought we would have got a hurricane here in Western North Carolina that would have taken us out for a couple months. So you really got to use your imagination and get the management buy-in to support that preparation. Those would be my three things: management buy-in, preparation, and networking with like-minded individuals.
Thank you. While we have you up on camera, can you comment on anything that as a chamber manufacturer, you might be able to help out other people at other sites that are experiencing loss of chambers or chamber services?
Yes, I think we manufacture humidity chambers, and so oftentimes people forget that the chambers are sealed. So based on the differing conditions inside and outside the chamber, you can actually flood the chamber without having any source of water, just the condensation can come out of the air and saturate everything in the chamber. That is a situation that I've encountered many times, but a lot of folks, you don't really think about a flood happening without there being any source of water. The water comes out of the air. So you really got to use your imagination based on the conditions that you're operating in, whether it's a stability room or an accelerated chamber, um, and take everything into consideration. Get your maintenance team in the room. Get some people with some different perspectives, some different experiences that might be able to lend to that imagination of the nature of the disaster, so that your mitigation plan can be more robust.
Okay, thank you. Aideen, you operate a stability storage, sample storage facility. It's in Ireland and dealing a lot with Europe. And I was going to ask you for your clients, what kind of preparations do you help them with for disaster planning?
So we are a multi-site corporation. So we have sites both in Ireland, in Belgium, and in North Carolina in the US. So we all operate under the same system. So um, I suppose our basis starts with real client collaboration. So we will talk to our clients, and the first thing we will do is we prepare a risk assessment. So we need the clients to be aware of what level of disruption that they can tolerate at a time, how long it's going to take them, how long do they think they need to fix their chambers before they have to activate their disaster recovery plan. And we look after all of that and identify the potential risks and their specific impact on their studies prior to the stability samples coming on site. So we have very clear communication right from the start, and we work with them very closely. Like no two disaster recovery plans are the same. It's not a one size fits all situation. It has to be tailored to each individual client, to their regulatory requirements, depending on what country they're in, and to the nature of their samples as well.
Well, thank you. Let's take a look moving on into some risk assessments, since you mentioned that as the most prominent piece. A useful tool that we've seen around for a long time is this equation, determining the degree of risk, and that's risk is equal to the probability of occurrence times the degree of severity over the likelihood of detection. So we have two factors that up the number and one factor that diminishes it in the divisor part of this equation. The greatest challenge is arriving at an acceptable scale to use for each of the terms, but once we establish this, we have a great tool at our disposal. So I also mentioned before that there's a lot of stakeholders. We identified over 30. Your partner for storage is definitely one, as well as your manufacturer of chambers, but you can also think about your maintenance crews, your security folks, people in the laboratory to assess kind of changes that have occurred to your product. There's tons and tons of folks that you can pull into your disaster planning. So in using this tool, we want to think about the various pieces of it. The probability of occurrence is a category that carries an advantage due to the availability of data in many cases regarding natural events in your area, as well as trending of equipment problems in many instances. So think in terms of how often hurricanes might hit, or how often earthquakes could occur, how often a piece of equipment breaks down. It's possible that you have some old equipment, and that if you see a trend in that equipment continually breaking down, you've got a good idea what the probability of occurrence is going to be. And then put that on a scale of some sort of thing, like how many days out of a whole year, X out of 365 is the number of breakdowns you have, or you could change it into something else over a different factor and use that as your calculation. Likelihood of detection is generally high with respect to weather warnings and fire detection, pandemics, that kind of thing. You know when they've hit, but it's also lower for earthquakes and computer hacking events where you have no notice of anything coming through. So a little bit trickier there. And degree of severity would be maxed out in the event of a chamber or sample loss, but much lower in those cases where samples are preserved for alternate conditioning. So all these factors are generally available to you to use, and you need to come up with your own system for determining what each one will be, what the basis is going to be. Thanks to Walter Routh for putting together a simplified scale chart for us and looking at some of the risks. And we've already, in this scenario, determined things like the probability, severity, and detection as high, medium, or low. And then you can see comparatively, if you look at tornado, probability of that would be low for this particular location that we've been thinking about hypothetically. Severity would be definitely high if one hits your plant directly. And detection would be medium, depending on what kind of a warning you got from your system, the weather forecasters around you. And so the calculation turns out a risk of 1.5. Compare that with a hurricane, was determined to be medium at the location, and hypothetically, we'll give it a 2, high for severity, and detection also medium of 2, comes out 3.0. So as you go down through this list, you can see some of the people that you'll be working with. Regulatory folks, people in your laboratory, your fire folks, weather predictors, a whole lot of those people would be involved in your calculations and your brainstorming there. And then on the end, you can compare some of these things and start to make some determinations as to whether you want to address them first or a little bit later on in the process. Earthquakes are not random, just discovered recently. If you look at the graphics there, in the California Bay Area, there's a 68-year quiet period between 1911 and 1979. And it was discovered that if you have a big earthquake, such as did occur close to 1911, it relieves the plate motion pressure for an interval that's hard to figure out. But the idea that the number of earthquakes go down during that particular process. So if you just had a big one, you can think that maybe another big one's not going to follow real quickly. But it's interesting to look. So they're not necessarily random. If you had one big one, you can't say that you're going to have one every single year to do that. So take that into your accounting. Hurricanes might be statistical, but are a recent big winner. The winner being actually a losing proposition. The Tampa-St. Petersburg area has an 11% chance of a hurricane impact in any given year. It's located by a shallow bay, Tampa Bay, and water piles up and runs into the city, causing very significant storm surges. There's been no direct hit since 1921, but 68 tropical storms and hurricanes have passed within 60 miles of the city. In 2004, a Category 4 Hurricane Charley caused $16 billion in damages when the storm made landfall just south of Tampa. And then just last year, Hurricanes Debby, Helene, and Milton all had severe consequences. 2 of those occurred within 2 weeks of each other. So trying to predict that is hard, but looking at the amount of damage in terms of impact, you can see that your equation and your risk is going to be quite high if you're in an area that hurricanes pass through. Another thing is loss of computing. Cybersecurity attacks such as ransomware and phishing attacks are growing threats. 66% of organizations experiencing at least one ransomware attack. And you can go to this link to 2023 survey by ISPE, gives some interesting statistics about that. System failures of software and hardware issues can also cause unexpected downtime. Planned maintenance figures in. Regular maintenance, upgrades, and patches can lead to planned downtime. And mergers and acquisitions, so the integration of systems during mergers can create temporary disruptions. And I know that I've experienced one particular site vice president that was really anxious about getting a new system in place. Decided not to wait for all of his IT people to come across with a conclusion as to what system to buy. So he ran out and overnight bought a system off the shelf and brought it back and ordered his people to implement it. But they could not. There was no basis for plugging it in and setting it up. He ended up putting it back to the original store he went to and paid a huge restocking fee. So those kind of things are almost man-made disasters and can cause some loss of computing. I mentioned Merck before, back several years ago, at least, if not 10 to 20 now, where I had a lot of colleagues that reported that they were at home during that period of time. And I asked if they were working from home, and they gave me a very shaky, yeah. and I suspect they weren't working from home because their system was down. But it can cripple us, and there's a lot of things you can do. The experts have things to do for barriers for people to get in, and also they can test their people to make sure they start recognizing some of these threats. I work for a company that put out a weekly Trojan horse where they sent out something very suspicious, or maybe not so suspicious. They had a contest. The first person to spot it and report in won a prize, and then the rest of the site was alerted to, okay, that was a phishing piece, and so many people within our company fell for it. So many decided not to. And in that way, they started effectively training everyone to be on guard for those kind of things. What do we want to tackle first? With risk levels established and priorities for remediation, we can set our priorities for what we want to do. By logical to address them in the highest to lowest order, other factors such as cost, regional susceptibility, and recent occurrences may change the order in which you wish to remediate them. You need to work with your corporate teams to establish your best plan. Let's stop for a second and ask Chris Latos, our representative from the medical device industry, what do you see in the way of advantages to doing this in tackling your plan? What's the benefit of a well thought out plan?
Well, certainly if you have the last thing you want to do is plan when you have an actual event that occurs. So, if you have a good plan, established, you have people trained on it, number one, it's going to reduce the level of stress when you have such a, disaster and an event and so forth. And it may very well help you, preserve your samples, your data, even the laboratory itself, depending on, the nature of the, disaster and what type of mitigation plans that you have put into play.
Okay, and thanks. And since you're a chamber guy, I've heard a lot of your presentations about chambers. Is there anything that people can be doing in the way of preparing their chambers, make sure that nothing's happening with them?
Yeah, I mean, a lot will depend on the nature of your sample. So if you have very temperature sensitive samples, so maybe if you're dealing with vaccines or monoclonal antibodies, something like that, where you need strict storage conditions at freezing or refrigerated storage condition. The last thing you want is the power to go out, and then you're not able to have power restored for a period of time. So having some type of backup system, backup power system, a generator, would be an important thing to consider. And another thing that could be taken into consideration, it's costly, but again, it really depends how critical your samples are. You could have redundant sample storage at another location. So if if your location has multiple sites, you could have redundant storage chambers, at another geographic area. So you have your stability samples, the same lot or batch, stored in multiple locations. In the usually it's unlikely, but in the unfortunate event that your building caught on fire and all your samples were destroyed, you could revert to the other facility with the samples. Same thing with the power. If power went out, your samples are destroyed, you can revert to the other samples that are stored at another location.
Yep, sounds good. I've heard a lot of people make use of that, whether or not they do a full study worth of samples to some place, or just put the bare minimum in a box and ship it off to be held just in case. Depending on your planning and your budgeting, that can make a big difference. Some of the disasters that we mentioned are kind of man-made, and I wanted to, before we go too far, ask Jeff Carr, as a person who's done a lot of work with CDMOs and also working with the company that I worked with at one point in the past. And I'll never forget, our company made a mid-course change almost overnight. and we dumped an entire project, if not more than one project, on your CDMO company. And you may or may not remember that specifically, but I wanted to just see if you could comment a little bit about what happens when somebody sends a lot of things your way overnight. Does that constitute a disaster for you as well as us, or the CDMOs to also engage in the planning to be able to do this? As I recall, your company came through with flying colors back in that situation, but can you comment on that, Jeff?
Yeah. Okay. Thank you, John. Yes, that could be a problem. It's happened to us a couple of times. I must admit, I don't actually recall the time that you were talking about, but it certainly has happened to us a couple of times. But the reality of it is that it doesn't really happen overnight. If a disaster happens somewhere, it's going to be quite a long time before they can actually send any samples to us. They've got to sort out what's going on in the place. Eventually, they might get round to deciding, well, we better do something about our stability programs. But even then, they've still got to now get all the paperwork sorted out. They've got to collect their samples together. They've got to be shipped under carefully regulated conditions to us. So the reality is it's probably going to be a few weeks before the samples actually turn up on our doorstep. So we do have some time to deal with it. Even then, you can't just dive in and start testing them, because you've got to now deal with new analytical procedures. It might be a disaster, but you still got to go through the correct steps to deal with them. You'll probably have to do some sort of analytical transfer of the methods to make sure that your people are trained to do them. And so at the time I would have been working with Thermo Fisher Patheon, we have a number of sites all over the US and a couple of sites in Canada, as well as in Europe. When we're hit with something like that, if it did come as a big thing, we could always transfer analysts from one site to another site to help out with the additional burden. Might require a bit of training, but we could cope with that pretty quickly. So it's all doable, and it does actually take longer. The reality is it takes longer than you think it's going to be.
Mm-hmm. So it sounds like preparedness and method transfer is especially important for people if they're faced with the sudden loss of their own laboratories.
Yeah.
We have a question came through. This one looks like generated from Walter. We have frequently had to relocate material from a failing chamber to a backup unit. If this process is proceduralized, is there really any need for extensive deviation documentation in such an event? Can we simply document the new inventory location and leave it at that? What would an inspector expect? That's an excellent question, being as each inspector has their own expectations. But Walter, do you have anything in mind from your experience? Having done that, what happened in your instance?
Yeah, I think the inspector would expect that you followed your procedure, and you should have a procedure that tells you you don't need to do an investigation if, under certain circumstances. And my experience, I think we had a certain amount of time. It was like an hour or 2 hours, depending on the severity of the outage, to move the material without having to do any sort of a deviation. You simply document the inventory change and location of the inventory change. So if it was outside of that time, then you would have to investigate, impact to the product. But otherwise, we kind of defined procedurally that is a certain amount of time and a certain severity of outage would not warrant a full impact investigation.
So a big difference whether or not you have procedures in place to turn it right. Okay, sounds good. And we did have another one came through. Emergency change control process is a good way to handle it if it's defined. Came from Christine Napier. So thank you for that comment. So having emergency control processes in place, we're going to talk a little bit more about the importance of procedures across the board in that respect. Thank you for that comment, and everyone else is welcome to add questions or comments via the chat. But in the meantime, we're about halfway through today's session, so I'll take this opportunity to invite those who are new to Stability Hub to visit our website, stabilityhub.com. Check out the featured publications, regulations, events, suppliers, the interactive forum, job opportunities, and more that we have there. And while there, sign up for our monthly newsletter, see what's new. Ask your colleagues to join you in subscribing to the newsletter, and you'll have a great discussion starter every single month. As part of the Pharmaceutical Stability Discussion Group, or PSDG, Stability Hub is exploring a return to live meetings, which we did for decades before the pandemic, where attenders can spend parts of 3 days asking questions, sharing information, touring facilities, meeting vendors and their services, and networking to gain lifelong professional contacts and friends. Current plans are to meet May 17th through 19th, 2026 in the Raleigh, North Carolina area. And we're looking for companies in the U.S. that would like to host future meetings at their facilities. If you'd like to learn more about attending or hosting such a meeting, please send an email to me at john@stabilityhub.com. We'd appreciate that. We're also looking for folks that are active in the pharmaceutical stability areas that might be on committees such as ICH or ISPE or any other kind of major stability impacting pharmaceutical effort to contact us and see about sending some information to us from time to time in the way of reports that we can pass on to all the other subscribers so that everybody gets some information before it becomes really old. We look forward to that kind of participation. Okay, returning to the program here. Detection and prevention best practices. It's said that an ounce of prevention is worth a pound of cure. Effective strategies include advancing preventive measures and improving ability to detect a threat. And while the probability of natural events generally can't be influenced, any internal risks such as water, electrical, human error, and computing can be mitigated through improvement initiatives. In earthquake zones, you could do things like putting barriers on shelf edges, tie down straps go a long way in sample preservation. I've worked in a few companies where I was in California, and that's exactly what they did. They anticipated that there would be earthquakes, and they put a nice barrier along the edge of every single shelf and tied down some other equipment. If you want to see how effective that was versus not doing anything, all you had to do was to walk down to your local grocery store and go to the wine section. And if the earthquake was moving bottles in the parallel direction, the bottle stayed on the shelves. But if the earthquake pulses were 90 degrees to the shelves, every bit of wine was on the floor and totally lost. So you can see it made a big difference whether or not you put up some barriers to hold your samples on the shelves. You can think of other things to do to prevent things along those lines. We had a very small but significant disaster in one of my early stability labs where two very energetic young employees decided to see how fast they could make the rolling shelves travel along the rails. Not thinking too much what would happen when it reached the end of the rail, and us not thinking in advance that we needed an emergency barrier at the top of the units. They cranked it down both together, built up speed, and it was like a giant train wreck. Everything went off the rails, samples spilled all over the place. And right at that moment, as luck would have it, our director came through giving a tour. He opened the door, he assessed the situation, and then he turned to the crowd and said, "We'll come back later," and moved away. And was not good, but we needed to be thinking about those kind of things. What should we not be doing? What should we be doing for safety's sake? And we soon installed a mechanism that made it so you couldn't possibly tip over a stability shelf. Chamber area rooms should have moisture alarms and floor drains to detect and channel water away from chambers. I've also had rooms that had no drains and water started to build up on the floor. And we had lots of electrical things that were plugged in on the floor. Engineering would have done great for that. And you could also engineer in things like awnings inside your chamber, catch shelves and diversion channels to protect any in-chamber samples that are residing under water lines from above. And also as a great preventative measure as well. Chamber sample bins should have drainage holes so they don't hold on to water. and maybe even a cover on the top with holes in it because you want air circulation for sure. But you don't want much water going into your bins. Regular maintenance is essential to minimize equipment failures. Chamber backup measures are prudent, though having a qualified empty operating chamber available nearby, or alternatively having a contract arrangement, like we spoke of just earlier, with an offsite GMP storage facility is a prudent thing to take, especially if they're a distance away from the risk zone. So those kind of things are great. Detailed procedures and frequent training in both disaster preparedness and response lessen the impact of disasters and hasten a return to normal operations. Can you pack up your stability samples and protect them for transport with a few hours' notice? Some people in North Carolina have gotten really good at that. Periodic drills with simulated samples for due caution and involving all potential participants from packers to receivers could be a wise investment to do. Frequently backing up protocols and data in the cloud preserves information when fire, wind, flood, or hackers intervene. To diminish the possibility of human error, leave no loop open, no receipt unsigned, and no checkpoint unchecked. There's a question. Water pipes and electrical lines are outside the sphere of influence of our stability group. How can we address them as part of disaster planning? We mentioned earlier the cloud of people that surround stability as our stability stakeholders, and the people that do the electrical and the plumbing in your building should be definitely part of your considerations, making them, I would say, members of the stability team. I always said I had a stability group, and that was the people who actually worked on the stability function. We also had a stability team, and that was everybody that had any kind of support, whether it was people who clean chambers, the security people that came around to check on them, the people who might take the samples in and out from other groups. We made all of them part of our stability team. We included them in communications. So if you do that with the people who are involved with the plumbing and the electrical, you can find out from them when they've got projects coming up that might turn water or power off or back on, or what's actually running through your room. We've had inspectors come through and ask us, what's in those water or those pipes that are unlabeled running through your room? We assumed it was water, and we found out it was, but it could have been something else. So they had a good point. So that's, you want to include them as part of your planning by making sure that they understand the importance of what's happening in the stability area and that they can have an impact on you. Detailed procedures and frequent training in both disaster preparedness and response lessen the impact of disaster. Oh, sorry, I'm moving backwards here. It had a very familiar ring to it. Why isn't disaster preparedness more prevalent or more sustainable? And most complete disaster plans are expensive to implement and maintain, as you notice as we've gone through some of these. The absence of disasters over the course of time, corporate cost cutting, and conservation measures will bring scrutiny and fiscal knives of the budget crew, who will point out that disaster planning measures have not been utilized in quite some time. Taking a disaster planning poll among our industry colleagues often brings the response, we used to have a plan, but it was discontinued. And they always give the answer why it was discontinued, because it was so costly and it had never been used. So that raises some questions about how do we preserve our plan? Having a vigorous defense ready for your plan, citing risk and cost factors associated with the loss of chambers and stability study samples, upon which success of new product registration lies. So calculate the cost of what it is to have a new product, the income that you'll have from that, what it would be to lose that, and then say, okay, so how does that compare with the price of having a disaster plan and having some of this ready? We can monitor news feeds. We can mine archives for examples and consequences of inadequate planning. There's a number of news stories out there about circumstances in which they lost their product, and that meant not only loss of material, but also loss of marketing advantage getting started on the market. So you end up with a me too instead of a product leader. We can aim for the most cost-effective measures when drafting a plan, maybe not go for the most expensive. Having an annual contract with a secondary storage facility and making at least minimal usage of it might be cheaper than buying a backup chamber or two and keeps your line item out of the capital equipment category. So you may not be successful in trying to buy new chambers, but if you go to a different category and say, okay, we have some services here that we want to make use of with a contract house, that might be a whole nother story to the people doing budgeting. Let me return back to Aideen about this kind of a topic here. Do you have people that aren't necessarily storing all their studies in your facilities, but keep at least some moving in and out in order to make sure they've got some backup and also to keep their contracts active, making sure that they don't have to start from scratch, maybe doing some kind of auditing ahead of time and then sending a few samples here and there. I'll let you comment on that if you would.
Yeah, of course. So we have contracts in place with clients who use us only really as a disaster recovery site. So either they will carry out a mirrored study so that we'll have samples here and they'll have samples on site in their own chambers, or they reserve space here in the event that one of their own chambers goes out of spec or goes out of condition. And then they know that our chambers are validated and temperature mapped and calibrated, so they know they can transfer the samples very fast. So we have both situations where we would have samples and we would also have spare chambers reserved by clients to prevent disaster.
Okay, thank you. I'm thinking a number of companies I've been familiar with have done similar things, both from the point of submitting and also accepting them. Also a note from Christy Napier. Also, don't forget to ensure backup to the temperature and RH monitoring systems as well as chambers. So yeah, that's important. And I think I have a good example of a near disaster that occurred in one of my companies during Christmas break one year. The folks that came through and did all the calibration work and updating the monitoring systems, that kind of thing, came in, do some maintenance. And so when they do that, they start monkeying with the chamber settings and that kind of thing, which is an important part of the process. So as a result of not having to listen to the alarms, they turned the system off. So they did that at Christmas time. They went in, made their adjustments, did everything they were supposed to do, and then they themselves left for vacation, not turning the system back on. So for almost 4 to 6 weeks, we had not one single shred of data coming out of our chambers as to what the temperature and humidity were, let alone not having any alarms. And so I wasn't responsible for that at the moment. When that occurred, there was a different group in the company, but they turned to me and said, how do we justify this? And I was thinking it's not too terribly justifiable. It really would help if you had some kind of a monitoring system to monitor for the monitoring, in that when data stopped flowing, an alarm would go off. Thinking it's normal to have some kind of a data flow coming out of all these chambers, and if that stops, somebody needs to be notified. And they would have been notified on the day they turned it off, and they would have known that that was a normal part of the operation. But by, say, midnight that evening, they would have known better that nobody was working on the chambers and there was no data flow and something was wrong. So instead of 4 to 6 weeks, they would have had 4 to 6 hours in the way of not having any data. And we were lucky to escape that. We had an explanation that we didn't notice anything unusual happening in our results, those kind of things, but we did have to implement some procedures to make sure that never happened again. That we didn't want to run into that.
That's a great example. We had a similar situation, and our IT guy came up with a solution to monitor the monitoring, not to check for lack of signal, but to check for lack of change in the signal, assuming all chambers are going to fluctuate, a certain amount within a minute or two, kind of. And so if they detected no significant or no change in signal, then they would send an alarm to me at home and just to look into it and make sure everything's okay.
Yeah, and the same kind of thing can hold for inside your chambers. I think Jeff Cook would know this better, that you can also monitor for any change in water pressure going in and out of chambers. And it should be one particular thing on a normal, I'm assuming there's a range there, but you can monitor for a change in that. If it suddenly drops, you might might no longer have your humidity system working. So lots of things here. I always advocate for being best buddies with your budgeting department. When I arrived at my most recent company that I worked for, I was only a couple weeks there when they said, "Okay, it's time for the annual budget. We need yours tomorrow." And I thought, well, nobody's told me what my annual budget is or even what the components of that budget were. And so I walked down the hallway to the lady who was part of the budgeting group, who didn't know me and I didn't know her, but we became fast friends. And she filled me in on everything that happened in the preceding years, what the trends were, typically what money I had available to me. And I was able to have a budgeting report the next morning that was fairly respectable. So make sure that among those 30 different stakeholders that we talked about, that budgeting is one of those, so that you know how much money is available, what's flown and what hasn't flown in the past when you're trying to buy something. Particularly if you spend some money or your predecessor spent some money on outsourcing, you would know exactly what that was. So get to an early summary here before we take more follow-up questions. Assessing risk, mitigating liabilities, planning responses, and practicing for every scenario is an effective approach to disaster planning, and continuous diligence and involving all stakeholders ensures the most effective response when the formerly unthinkable comes to pass. You have a comprehensive and well-practiced plan. So we're hoping that you all go back home. Well, actually, you are home. We're not in a live meeting. You go back into your office and start thinking about some of these disaster plans. If you don't have one, it's a good time to get started. And if you do have one, recommend that you revisit it at least annually. Or if you have a problem, that's a good time to sit down and kind of analyze what lessons have been learned, what you need to tweak, what you need to mitigate, looking at anything that's left undone, and having a plan that you can just pull out and follow. I was thinking back to 2001, the World Trade Center, where the entire companies were located in one building and most of their staff was wiped out along with all the equipment. What the person that would be in charge of the company had to do in order to get back on their feet. And similar obstacles would be facing us if we had a disaster. What would you be able to do in order to pick up the pieces? Maybe you're not familiar with anything, but if you can go to a file and pull out a plan that says, in the case of, let's say, flood, do this, assess this. Here's the people who supplied the equipment that we have. Here's the insurance people that can talk to you. Here's the stakeholders that can reestablish what you need to have reestablished. Here's where your samples are for emergency basis. We got them contracted out here and there. Contact and notify those people. Say now you need to activate some studies. A whole lot of different scenarios that you can think ahead of time as to what you need to do, and write up procedures for each one in case you do experience a catastrophic loss, where you can have somebody know that you have a plan and they can pull it out and just start to follow it, even if they're not familiar with all the pieces. It's definitely a good place to get started. Let's see, another question came in. There are also predictive systems separate from the GMP monitoring systems that monitor the major components of the system that can be utilized. So yes, predictive monitoring, I think, is the commercial name for that. And it's a great new system, new technology, where you can start to monitor your chambers and see well in advance that something is going astray with each one, and have that fixed before it becomes a major problem. So definitely do look into that if you're worried about your stability chambers, you can monitor those and see when something's coming down the line to do that. There was one point in my career where we were not buying anything new for quite a while, and my chambers got older and older. And we spent more and more time trying to operate them and adjust them, and we started doing it more manually than we should have. And then when we called for recalibration and revalidation, we learned that they were no longer revalidatable because they had gotten into such bad shape. So knowing that kind of stuff in advance, knowing how long your equipment's going to be good for, is a good way to add that into your disaster planning. So time for questions here. This is your time to raise those. We have some that are on our files here that we're glad to talk about, but we're more interested in what kind of questions you might have. Well, in the meantime, Chris Latos, can you tell us why it's a good idea to have a hard copy of your disaster plan? We just spoke about having it on file. Why would we have a hard copy? I've heard the other argument go through about hard copies are things that can get destroyed in floods, but there's also probably a good way to think about having a hard copy as a benefit.
Yeah, so if if you lose power, if you have some type of cyber attack, you have electronic copy, you may not be able to access it. So it's a good idea to have hard copies, available to at least, key stakeholders of your disaster plan. The downside with that, of course, is, you have hard copies, they're not a controlled document. So, if you do like an annual review of your disaster recovery plan, maybe you make some revisions in the electronic system, you got to be darn sure that everybody who is issued a hard copy also receives the updated, version in hard copy form. So that's the downside is, you could have stray copies out there, then, you have a disaster, somebody follows an old disaster recovery plan, maybe have phone numbers from, people that have left the organization or, equipment vendors that you no longer use or people left, those companies as well. So there's positives and negatives, but yeah, if good idea to have hard copies, just make sure that, they stay updated and, you don't have stray copies dangling out there.
Okay, thanks. Another question, any particulars in mitigating loss of computer risk? I think that the key there is to work with your IT department for retrievable backup storage and training people to recognize the threats, having procedures to operate manually if you experience a significant loss of computing. I once worked as a consultant for a company that was implementing a new computer system, and they wanted to start from scratch. So first thing we had to do was build a manual system that they could mimic. And then once they activated the computer system, the manual system became the backup and made it easy to turn to once the computer system went down for whatever reason. And the nice part was that since they based everything on the initial manual system, we were totally compatible with what they needed to do. So you could capture data manually, hold on to it, and then enter it in when the computer system came back up. Some companies even have ways to capture that data electronically and hold it someplace before it gets entered back into the main system. Does anybody else have any questions about the IT part of that or anything about the digital aspect of it? We'll watch the chat for that. We mentioned earlier the FDA and others call for disaster planning, even though if they don't cover it in the regulations. How would we engage our quality unit to come up with disaster plans when there's not a regulatory requirement for that? And I think the answer there is to look to some of the warning letters and 483s that are out there that the FDA has it not as a guidance or a requirement, but as an expectation that you have a disaster plan. They want you to manage well, and if you don't have one, you're basically not managing well. So I think you can think of the 30-day requirement as something that is an expectation of the FDA, but you won't find in any guidances that they put out. So these expectations come to pass when they start looking at industry and seeing what the standards are. They would expect us to have a disaster plan or some kind of a plan to take over when there is a problem. And I think that would be effective in getting your management engaged. What is the 30-day requirement? Okay, so I use it. I guess it's a fair game question. The 30-day requirement was an expectation that if you put your samples out and submit them that within 30 days you complete your analytical testing, unless you have some kind of a valid and defendable rationale for not having it within 30 days. They like to see that back in 30 days. And we've also seen some warning letters and some 483s assigned on people didn't consistently meet that requirement. So if you're going to take more than 30 days, you want to have some good justification. It could be a particular kind of test, like a microbiological test, those kind of things. And there's also 30 days that gets applied to a number of other places, submitting your samples, completing your tests, and then completing reviews. Okay, and it's nice to see that we're being helpful to people who are new to stability. So we'll continue that. Another question was, is there a secret to discovering industry best practices in disaster planning and for any other aspect of stability for that matter? We're kind of biased in that respect. We think that industry resources such as Stability Hub, AAPS, ISPE, et cetera, have great literature and meetings. So we're thinking the PSTG spring meeting next year in Raleigh as an opportunity where people actually meet and actively share their experiences. And this meeting is actually to be mimicking that sort of thing. In the absence of live meetings, we try and get together electronically and chat with each other and share our experiences. And people go home with life-saving, industry-saving kind of ideas to meet the needs that they have. And it's all because they shared back and forth, not proprietary information, but just procedural information. And it's a great help to each other to do that. Any final question? Okay, we have about 3 minutes. We have one more. We'll go to Aideen for our last question. And any particulars in your company's preparedness for disaster plans within your own situation, not just your customers?
Sorry, I muted myself. So for our own internal preparedness, if you like, we have regular disaster simulations and audits to check that we can act very quickly if something does go down. We have redundant power systems and backup generators that are checked on a regular basis to make sure that we're never in a situation where we have a power outage and all our chambers go down. Because obviously that's the crux of our business across our 3 sites. So we have to make sure that we have power consistently. We have fully trained team that will act very quickly in emergency response procedures. And we have validated transport and sample management systems to make sure that everyone is trained and everybody knows what they're doing, and there's no confusion when a disaster arises. So our facilities across the 3 sites allow us to mirror critical studies. So if one chamber or location is impacted, say if we were impacted here in Waterford, then another site, our sister site in Belgium or in the US can step in and take over a particular study if needs be.
Great information. Thank you. That sounds like practice is the key. We've arrived close to the end of our program here. I'd like to thank our panel members and all who attended today. We hope you take away some information that will help you launch or improve your disaster planning efforts. To protect and preserve your stability operations, please join us again for subsequent programs in the Stability Hub webinar series. The August webinar explores the alarming presence of nitrosamines in our stability products and how we can use the latest guidances to comply with emerging methodologies in identifying and dealing with those. September is a discussion of the newly condensed ICH stability guidances. October brings an office hours webinar to address all your questions with over a variety of stability topics. We'll pick up the chamber theme again in November with how to deal with chamber excursions in regard to both equipment and products. The 2025 series concludes in December with a session on outsourcing and contract organizations. And the webinar schedule can be found in the events section on stabilityhub.com and in our monthly newsletter. We hope you can join us often. That'll wrap it up for us. So we wish everyone to have a good day, and we'll hope to see you again. Thank you.
Thank you.
Thank you.
Thank
The
you.
recording